NASA finds organic molecules in 12-billion-year-old galaxy and a mystery. The James Webb Space Telescope spotted complex organic molecules in a galaxy that existed only 1.5 billion years after the birth of the universe. Astronomers spotted complex organic molecules in an ancient galaxy that existed only 1.5 billion years after the birth of our universe, setting a new record for the most distant detection of these key cosmic compounds, reports a new study. The discovery revealed that polycyclic aromatic hydrocarbons, PAHs, a class of molecules found in smoke and soot, are distributed across this faraway galaxy in an unexplained pattern that raises new questions about the early evolution of stars and galaxies. PAHs have a noxious reputation here on Earth because they are often found in coal, oil, smog, and other pollutants that present risks to health, public health, and ecosystems. For astronomers, however, these compounds are stellar smoke signals that point to regions where stars are being born at a very high rate, making them reliable tracers of star formation until now. A team led by Justin Spilker, an astronomer at Texas A&M University, used the James Webb Space Telescope, the most powerful observatory ever launched, to search for PAHs in an ancient galaxy called SPT 0418-47. Spilker and his colleagues found that these compounds were often abundant in areas of low star formation and scarce in places where lots of stars were being born, a finding that remains unexplained according to a study published on Monday in Nature magazine. I think of this as a little like where there's smoke, there's fire, not only because these molecules show up on Earth in smoke, soot, and smog. Spilker said in an email to Motherboard, if you think that these smoke molecules tell you that new stars are blazing away, then everywhere you see young stars, you should also see these molecules and vice versa. Instead, we found that there are some parts of the galaxy with smoke molecules but no fire, and some with fire but no smoke. And this could happen if all of these molecules were destroyed somehow. For example, if shock waves from supernova explosions blast them apart, or it could be that for the same reason the light from the newborn stars is not as closely connected to these molecules as we thought it would be, he said. We're not really sure what's causing the differences between the organic molecules and star formation at this point. We've got a lot more work to do to understand this. Spilker and his colleagues observed SPT 0418-47 was part of the James Webb Space Telescope program called Templates, with aims to better understand star formation in galaxies that existed within the first few billion years of the universe. The program is focused on a group of galaxies that are naturally magnified by a process called gravitational lensing, which occurs when light from a distant object, such as a galaxy, is amplified by the gravitational field of an object located closer to Earth along our line of sight. SPT 0418-47, which is initially spotted by the South Pole Telescope, is almost perfectly aligned with a galaxy in the foreground of our observations, causing it to split into a bright multi-part image known as the Einstein ring. This galaxy has been a long-time favorite of mine, says Spilker, referring to SPT 0418-47, adding that it was a really obvious target for our first observations with Webb. We knew that no matter what this galaxy was going to look like, it was awesome. It would be awesome. The big picture goal of Templates is to dissect new star formation in distant galaxies, he said. There's a lot of different ways astronomers use to try to estimate whether a galaxy is making new stars quickly or slowly, and these molecules are one of them. The idea down the line is that we'll compare all these different methods and try to figure out if they agree or disagree and why. The big picture goal of Templates is to discuss the star formation. James Webb new observations hint that the evolution of organic molecules in early galaxies is more complicated than previously expected. The standard correlation between PAHs and star formation that has been observed in younger galaxies seems to break down in this galaxy, which indicates that some mechanisms has some mechanism has produced spatial variations of the molecules within SPT 041847. Spilker and his colleagues speculate that the variations might be shaped by the explosive deaths of stars in the galaxy or the distribution of dust grains across it, but a clear explanation remains elusive at this point. What's certain, though, is that this is the earliest glimpse of such complex compounds in the universe, which confirms that galaxies were chemically advanced even in this ancient age. This is definitely the most distant detection of the molecule so far, he said. We're seeing this galaxy when the universe was only 1.5 billion years old, just 10% of its current age. Despite that, this galaxy has managed to have enough stars be born, live, and die to enrich their surroundings with heavy elements like carbon and oxygen. The PAH molecules we found are not small either, he said. Water, H2O, only has 3 atoms, but these PAHs can have thousands of atoms, so that means that this galaxy, even though the universe is very young, has had enough time to both create lots of heavy elements and for those heavy elements to form up into these really big complicated molecules. It tells me that making a lot of these big complex compounds must actually be pretty easy to do, because otherwise the universe would not have had enough time for such complex chemistry to take place, he said. PAHs may have played a role in the emergence of life on Earth, which has made them a topic of interest in the search for extraterrestrial life. However, Spilker said that the new study is not directly applicable to the effort to find aliens or to assess the habitability of distant systems, though they do demonstrate that complex chemistry has been abundant in the universe for at least 12 billion years. The universe can create these really big molecules even in clouds in interstellar space. We don't even need planets for these molecules to show up, he said. If the universe can make big molecules like this even in space between stars, it's not crazy to think that this would also be happening on any planets in that galaxy. This tantalizing glimpse of familiar chemicals in such a far-flung location is just the latest discovery from James Webb Space Telescope, which has only been operating for a year. Spilker and his colleagues hope to build on their findings with future images from this unrivaled observatory, which may ultimately explain the weird variations reported in their new research. We've got lots of directions to try, he said. For templates, this is really just the beginning, and we have all the hard work yet to come of trying to understand the best or the least bad ways of figuring out how fast galaxies are growing. For PAHs, I would like to try to push to even larger, earlier galaxies. I think that'd be really interesting if we eventually find galaxies that are young enough that these big complex molecules just have not had enough time to form yet. On the other hand, if we keep finding them earlier and earlier, I think it really says that the chemistry of the early universe must have advanced really rapidly, so even planets that were born billions of years ago had all the same ingredients as our solar system did when Earth formed, he concluded. And this is by Becky Ferreira on Vice. Please leave your comments, and thank you for your support. My Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.